Welcome back, guys. In today's video, we'll be learning how to find the LCM of two or more numbers using the index method. Let's dig in. An index, also known as an exponent, is a small number that shows how many times a base number is multiplied by itself. Indices are used to represent repeated multiplication. Now, for instance, what that definition means is that the number 8, for example, can be expressed as 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. Now, this is an example of a repeated multiplication. We have 2 multiplying itself 3 times. In index form, this can be written as 2 raised to the power of 3. It shows you how many times the multiplication of 2 is done. And in 2 raised to the power of 3, we call 2 the base, and 3 we call the power or index. So if you look at our definition of index again, it says it's an exponent and it's a small number that shows how many times a base number is multiplied by itself. So in 2 raised to the power of 3, 2 is the base and 3 is our index, and it shows us that 2 multiplies itself 3 times. So generally, when you're asked to express a number in index form, what you have to do is to break it down and show that number as a product of its factors, normally its prime factors. And then you're going to put that in index form in situations where that there's a repeated multiplication in your expression. For example, in 10, 10 is expressed as 2 times 5. Now we can't break this down any further. And if you're asked to put this in index form, you'll notice that in 2 times 5, there is no repeated multiplication. We just have 1, 2, and 1, 5. We don't have 2 multiplying itself. We don't have 5 multiplying itself. So since there is no repeated multiplication here, if you have to put this in index form, it's just going to be 2 raised to the power of 1 times 5 raised to the power of 1. So the power there comes from the number of time the base multiplies itself. So we're going to go ahead and apply this concept of index form to find our LCM. And we have the first example here on our screen. Find the lowest common multiples of the following numbers. We have 8 and 12. So to begin, we're going to express both numbers as a product of their prime factors and then put it in index form, and I'll show you how we can use that to find the LCM. So 8 is the same example that we just looked at now. You have 8 equals to 2 times 2 times 2. And in index form, we're going to write that as 2 raised to the power of 3. And then we have 12 as 2 times 2 times 3. In index form, this is going to be 2 raised to the power of 2, because we have 2 2's here, times 3 raised to the power of 1. Now we've expressed both numbers in index form. Before I go ahead to show you how to use this to find LCM, in case you're wondering, how do I do this breakdown? If you're not familiar with breaking down numbers straight away like I just did, I'm going to come to the corner here and show you how you can go about that. You can do it step by step. For example, I know that 8 is equals to 2 times 4. That's the start. And I can't break down 2 any further, but I can break down 4. You know that 2 times 2 will give you 4. So you can go ahead and break this down again as 2 that's these two here, times, and then break down your 4 to 2 times 2. So that's how we're arriving at what you can see on the left hand side here. The same goes for 12. If you can't break down 12 straight away into 2 times 2 times 3, you can begin by breaking it into 2 factors first. You know that 12 is 2 times 6, right? 2 is in the lowest form already, but you can break down 6 to 2 times 3. So 2 times 2 times 3 will give you 12. So that's how you come about this expression on the left hand side. So moving on, you have expressed this in index form. How do you use that to find your LCM? Now, what you have to do is you look at the base you have on both lines. For 8, you have 2 raised to the power of 3, and for 12, you have 2 raised to the power of 2. So what you have to do is to compare the powers or the index where the bases are the same. So 2 is the base here, 2 is the base here, they are the same. For the first one, the power is 3, and the second one, the power is 2. You pick the base that has the highest power. So because 3 is greater than 2, we are going to pick 2 raised to the power of 3. And then you can just forget about this one. It's already represented in here. And then you move to the next base. For the first number, 8, the only base there is 3, is 2 rather. So we're done with that. But for the second number, 12, we have 3 raised to the power of 1. Now, there is no other 3 to compare this base with. So we're just going to pick that as the base with the highest power. Say there was another 3 here, 3 raised to the power of 3 or 3 raised to the power of 4. Any power at all higher than 1 means we'll pick the other base instead. But since this is the only 3 here, we're going to pick that as 3 raised to the power of 1. So to finish the LCM here, we're going to do an expansion and a multiplication, or you can just go ahead and do the multiplication straight away, but it helps to expand before you multiply, so it makes it more easy for you. So this is going to be equals to 2 raised to the power of 3. We know it's 2 times 2 times 2, and 3 raised to the power of 1 is just 3. So now we multiply. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So it means that the LCM of 8 and 12 will give us 24. Now, if you've been following the series, for the first 2 methods of LCM, we also found the LCM of 8 and 12 using the other 2 methods, and you can see that we arrived at the same answer, 24. So let's go ahead and check out another example. Find the LCM of 10 and 18. So just like we did for the previous example, we'll express both numbers in index form and then we'll find the LCM. I think we're going to move faster now. So we know that 10 can be expressed as 2 times 5. And just like I explained earlier, there is no repeated multiplication here. In index form, this is going to be 2 raised to the power of 1 times 5 raised to the power of 1. Now for 18 can be expressed as 2 times 3 times 3. Again, this is going to be in index form, 2 raised to the power of 1 times 3 raised to the power of 2. Let's go ahead and find our LCM. It means that our LCM will be equals to, we have 2 raised to the power of 1, 2 raised to the power of 1. The bases are equal, so just pick one, any one of them, 2 raised to the power of 1, and that's that. Times, following the order, after 2 we have 3. There is no representation of 3 in 10, so obviously the highest power of 3 here is going to be this, 3 raised to the power of 2. So I'm going to pick that. Remember, if there was another base of 3 with a higher power in the first number, that's what we're going to pick. But since there is none, we pick this one. And then we have one more base there, which is 5. 5 raised to the power of 1 is the only representation of 5 in the both expression as well. So pick that 5 raised to the power of 1. If there was another 5 here with a higher power, that's what we'll be picking. But since there's none, 5 raised to the power of 1 is what we will use. So I'm going to expand this so that we can multiply. 2 raised to the power of 1 is just 2. 3 raised to the power of 2 will be 3 times 3. And then you have 5 raised to the power of 1, which will be just 5. So to expand this, 2 times 3 will give you 6. 6 times 3 will give you 18. And then 18 times 5 will give you 90. So it means that the LCM of 10 and 18 will be 90. So we're going to look at one more example on LCM using the index method. And this time around, we're going to be finding the LCM of 3 numbers, 15, 20, and 25. And it's just the same way we handled the two numbers. That's the same way we're going to handle these 3 numbers as well. So let's begin by breaking down 15. So 15 is just 3 times 5 in index form, 3 raised to the power of 1 times 5 raised to the power of 1. We'll do the same for 20. 20 can be expressed as 2 times 2 times 5. In index form, that's going to be 2 raised to the power of 2 times 5 raised to the power of 1. And finally, we have 25, which is expressed as 5 times 5. It's a perfect square, so that's pretty easy for you to break down. And then in index form, this is going to be 5 raised to the power of 2. So now that we've done our expansion and we've written in index form, what will our LCM be? So I'm going to go ahead and write LCM is equals to, and compare our base. We'll start with the small one. We have 2, we have 3, we have 5. So let's begin with 2. This is the only base 2 we have. So obviously that's going to be our peak. So we'll take 2 raised to the power of 2 times, and for 3 also, we only have 3. There's no other base 3 to compare it with. So let's pick 3 raised to the power of 1 times. Now let's look at 5. We have 5 raised to the power of 1, 5 raised to the power of 1, and 5 raised to the power of 2. So we're going to pick, of course, the one with the higher index, or the highest index in this case, which is 5 raised to the power of 2. And then we just forget about the other ones with power 1. So 5 raised to the power of 2. And let's go ahead to expand and multiply. So we'll get 2 times 2 for 2 raised to the power of 2 times 3 for 3 raised to the power of 1 times 5 times 5 for 5 raised to the power of 2. So let's go ahead and multiply this. We say 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. And 60 times 5 will give us 300. So it means that the LCM of 15, 20, and 25 will give us 300. So that's it on our lesson on LCM using the index method. And as always, I have classwork here for you to try. Find the LCM of the following numbers. So we've got 3 numbers there for you. So go ahead and try that. And as always, feel free to submit that to the email on your screen. And I'll be happy to look at them and give you feedbacks where necessary. So that's it for today's lesson. Please check out our next lesson on factors. Thank you for watching. Don't forget to like, share, subscribe, or follow. and turn on our notification button so you know when a new video is uploaded. Thank you guys. See you in the next one.